Hi students, now we are going to learn about a new topic, namely angular momentum. First of all, in translatory motion, we have studied linear momentum, is it not? So the quantity of translatory motion associated with the body. So mathematically, what is linear momentum? It is the product of the mass and linear velocity, is it not? Okay, who is playing the role of mass in rotational motion? That is moment of inertia. And who is playing the role of velocity here in rotational motion? Angular velocity. So similar to mass into linear velocity, now we are going to derive an expression, but moment of inertia into angular velocity. Okay. So first let us define what is meant by angular momentum, and then we will derive an expression relating the angular momentum and the angular velocity. Okay. You can look at this picture. The rigid body whose boundary is shown by red, okay, is fixed about an axis passing through a fixed point O. So when the entire body is going to rotate, each and every particle present inside the rigid body, each and every point mass is revolving in a circular path. Okay. So whenever these point masses present inside the rigid body revolve in a circular path, they possess two velocities, is it not? One is linear velocity v and another one is angular velocity omega. Okay. Now first let us take the linear velocity of the particle. So the linear velocity of the particle is having a direction which is given by the tangent drawn at this point. So how will you find the direction of the linear velocity in circular motion? By drawing a tangent to the circle at the point. So now I have drawn a tangent at this point mass, and this tangent gives the direction of the linear velocity. It makes an angle theta with the direction of the position vector r. So now the mass of the particle m multiplied by the linear velocity, it will have a linear momentum. The particle will have now what? Linear momentum first of all, is it not? Then only angular momentum. So the product of its mass and this linear velocity will give a linear momentum to this particle first of all. In addition to that, it will have angular momentum. Understand? Now what is the linear momentum? Is mass into linear velocity. And what is the direction of the linear velocity? It must be along the same direction of this velocity. So p vector, small p is the linear velocity. It is a vector quantity. Understand? So the direction of linear momentum is along the direction of the linear velocity. Okay. Now what is the angular momentum? Let us define first. So angular momentum is the turning effect produced by the linear momentum. Once again, when a string attached to this body is pulled along this direction of this velocity, now the velocity vector, okay, it is going to rotate about the fixed axis, so that the momentum of the particle will produce a turning effect. This turning effect produced by the linear momentum only is called as angular momentum, which is also called as what? Moment of the linear momentum. Understand? Moment of a force means how did we derive? R cross product with F. Like that, moment of linear momentum means how to write? It must be R cross P. Understand? So this must be equal to what? Position vector or radius vector cross product with linear momentum vector. And this angular momentum only is represented by capital L vector. Therefore, L vector is equal to R cross P, where R is the position vector or radius vector and P is the linear momentum vector. Understand? So this is now equal to R into P into sine theta into the unit vector n cap perpendicular to the plane containing R and P vectors. So this is in vector form, is it not? Now magnitude of this angular momentum is given by L is equal to R into P into sine theta. This is the magnitude of the angular momentum. Understand? So this once again can be written in two ways. So this is equal to R into P sine theta. So if you take this is P, along this direction of R, this is P cos theta. And perpendicular to this will be what? P sin theta. This is one way. Like that, if you split or resolve R into two components, one along the direction of P and one perpendicular to the direction of P, this also can be written as what? R sin theta into P. Both are one and the same. So this can be represented as what? R multiplied by the perpendicular component of P. Like that, this can be represented as what? The perpendicular component of R multiplied by P. Understand that? So this is the expression for the magnitude of the angular momentum. Actually, angular momentum is a vector. Since it is a cross product of R vector and P vector, the direction of L vector will be either upward or downward, perpendicular to the plane containing the two vectors R and P. Is it not? By right hand screw rule. Okay. So this is the angular momentum vector. Now, if theta is equal to 0 or 180 degree, then sin 0 is 0, sin 180 is 0, therefore what is L? L is equal to 0. And if theta is equal to 90 degree, then sin 90 is equal to 1, therefore L is equal to what? R into P, and this only is the maximum value of the angular momentum, R into P. Okay, now what is the unit for this position vector or radius? It is meter. And what is the unit of linear momentum? It is kilogram meter per second. Therefore, what should be the unit? What should be the unit of angular momentum? This must be kilogram meter per second into again meter. So this must be equal to kilogram meter square per second. Okay. So what must be the dimensions of this angular momentum? So the dimensions of angular momentum, kilogram is mass, so this is capital M. This is meter square, so it is L square. And this is a second power minus 1, so T power minus 1, M L square T power minus 1. So my dear students, what is meant by angular momentum of a particle we have defined. Like that, if you take the summing up of the particles, all the particles of the rigid body, then you will get the angular momentum of the entire rigid body itself. That the next topic we are going to derive the relationship between angular momentum and torque also. Understand? Okay, fine. So what is the angular momentum in general, whether it is a rigid body or a particle, means angular momentum is defined as the turning effect produced by the linear momentum, or it is also called as the moment of the linear momentum. Okay, fine.